All right. We have this system, and we're going to use partitioning to break up this system into a subset of submatrices, and then you work on or analyze the smaller subsets or submatrices uh, to make this problem a little bit more tractable, a little bit easier to deal with. Okay. So with submatrices, when you're partitioning your matrix, you can partition them however you choose. The one caveat to that is to make sure that however you choose to break up the matrix into these submatrices, that if you're going to do any matrix multiplication, you have to partition these in such that your system still works together. Okay. Otherwise, you can partition it that way, but it's not going to get you any further. Okay. So for this particular problem, I'm going to partition it along these lines like that. So I'm going to make it that way. And part of the reason is that it produces a nice 3 by 3 matrix here. I have a bunch of zeros here, and it gives me isolates this unknown and allows me to isolate these 3 unknowns since this known is already given. Okay. So with that, then, um, if I look at the system, my matrix A, I'm partitioning it in the form A1, A2, A3, A4. I'm partitioning the column matrix of unknowns. Let's call that B1. That should be X1, and this is X2. I'm writing these as capital X's to distinguish them from the lowercase variables that we don't know yet. And then capital B1 and capital B2. Okay. Where above this line, so this is a singlet, that's my B1. My B2 is this column vector. My X2 is this column vector. My X1 is this singlet. My A1 is this single a matrix with one element, and then my row vector here is my A2. This is my A3, and then this 3 by 3 here is my A4. Okay. So now that we have the system partition, that was the first part. The second part, so this is part A of the problem. Part B asks us to carry out the resulting multiplication of the submatrices. Okay, so that's just really saying write this as a linear combination of the submatrices. And so I have A1 times X. So I've chosen my submatrices to multiply with this, the corresponding. So this is A1 times X1 plus A2 times X2. So that's this one. And that's going to be equal to our B1 result. And then the other one will be A3 times X1 plus A4 times X4 is equal to B2. Okay, so there's the matrix multiplication written as a linear combination of those pieces. Okay, and then part C asks us to find the unknowns here, X2, X3, and X4. Okay, which really means we just need to focus on this bottom equation here. Okay, so A3 was writing it out explicitly, and then X1 was the 2 here, plus A4, which is going to be this 3 by 3 here. So 8, -4 is 0. Yeah. -4 is 6, -2, and then 0, -2, 2 times X2, X3, X4. And so that's my corresponding B2, and that's going to equal then my B2, which is 0, 0, 4. Okay. All right. So multiplying this, you're just going to double all the elements here, which means that you basically have a -8. And so this is -8, but I'm going to add that term to both sides to make this equal to 0 to 0 it out. So I'm going to add 8, and that'll give me a 0 here, which means I'm going to add 8, 0, 0 here. So I'm adding this vector to both sides to cancel out. And what that's going to give me is the opportunity to see this as 8, -4, 0, -4, 6, -2, 0, -2, and 2. And I'm going to write it as the augmented matrix, but I'll write it in this form. So it's 0 plus 8. So I'm adding these components just so you can see where they're coming from. 4 plus 0. Okay. So this is obviously going to be 8, 0, and 4. Okay. So now that I have that augmented matrix, I'm going to go ahead and switch over to technology to do the row reduction. All right. So now that we have our technology, I'm gonna go ahead and enter in this matrix. I have 8, -4, 0, and 8. My second one will be -4, 6, -2, and 0. And my third row is 0, -2, 2, and 4. Okay. All right, so there's my matrix, and I'm going to look in my algebra. This is my algebra view. This is my CAS view. I'm going to do reduced row echelon form of the matrix M1. Okay. And so if you look here, then that's telling you that x2 is equal to 3, x3 is equal to 4, and x4 is equal to 6. So from the technology, we saw that x2 was equal to 3, x3 was equal to 4, and x4 was equal to 6.